Another very useful thing is free body diagrams and net force equations. We use them a lot in Physics IB1, especially in the first semester, but they will come back again. So, these are the common forces that we talked about. The one that we used all the time was gravity, Fg, also known as weight. An object's weight is the force of gravity acting on it. And gravity always points straight down. It doesn't go off to in angles or anything. Don't worry about breaking up in the vectors. We're going to analyze it slightly different. Gravity is going straight down, okay? Tension was another common force. When you're pulling on something, a rope or a cable or something, a bungee cord, tension always goes in the same direction of the rope and the string, whatever direction that you're pulling, right? Friction always goes in the direction opposite of motion. So what you have to do when you think about that is which way is the object moving? Is it moving this way? Friction goes exactly opposite of that motion, exactly opposite. Normal force or reaction force is always 90 degrees to the surface. So if there's a surface, if the object is on a surface, if it's standing on a surface or sitting on a surface, or if it's pressed against something, a surface, it's always going to be 90 degrees to the surface. So just imagine what the surface looks like. It's like this, it's like this, is it flat? And the object's going to be going 90 degrees to that, either up and down, or off to an upward angle like that, 90 degrees to the surface. Centripetal force, if there's orbital motion, like if I'm orbiting this pen with my finger or something, there's got to be something pulling that in. So centripetal force always points towards the center, exactly towards the center. Figure out where the center of the circle is. It's not flying outward, it's not flying in the direction of motion, it's going exactly towards the center. So if I'm out here, the centripetal force would be this way. If I'm up here, centripetal force would be back this way. If I'm back here, centripetal force would be going towards the pen. So it's always towards the center. Figure out where the center is, draw an arrow towards it. Applied force, that's just the direction that's being pushed. So if I push something this way, the applied force is exactly that direction. And finally, the net force, the most important one, the one that we need to use F equals ma to figure it out. What you do is you just draw all the other forces, and then whatever's left over is the net force. So let's do an example. Let's say Appa here, poor old Appa, he is getting pulled away by the sandbenders. He's on the sand, and the sandbenders have captured him, and they got a rope tied to him, and they're going and pulling him up like that. So there's a rope here, and there's a harness. All right, so what are the forces acting on Appa? Well, let's go step by step. Is there gravity? Yeah, there's always gravity, unless you're way out in distant space, but even then, there's gravity. So we're going to draw gravity going straight down. All right, gravity always points straight down. Is there tension? Is there a rope pulling him? Yes. Which way is the rope going? Well, it's going up this way. So I'm just going to draw an arrow up and right. I'm going to put it right on that rope. It's exactly the direction it's going. It's going right on that rope. Is there friction? Yeah, unless it specifies as slippery surface or something, there's going to be friction. Which way is Appa going to move? Well, Appa, if they're strong enough, they're going to make it move this way. So if he's moving this way, friction goes exactly opposite, which is that way. So friction is going to go this way. All right. Is there normal force or reaction force? Well, yeah, he's on the ground. He's on the ground, so the ground is this way. Which way is 90 degrees to that? Well, straight up. 90 degrees is straight up. Fn or Fr. Is there centripetal force? Is he orbiting? Probably not. But if they were swinging him around in a circle, then let's say they were swinging around this way. Which way would the center of the circle be? Well, it could be pointing this way or back towards the wall. It'd be that, but that's not happening. Is there applied force? Yeah, applied force and tension here could act as the same thing. So you could call this applied force or tension. Don't need both in this case. So the net force, what's left over? Well, what you do is you start canceling stuff out. Does gravity and normal force, does the upward forces cancel out, in other words? And we can think about, well, is he moving up and down? No. If he's not moving up and down, that means that they cancel out. So there's no up and down force. Do the left and right forces cancel out? No, probably not. Maybe, if he's not moving, then yes, but we're going to assume he moves. So the rightward part of this force, there's a component of that force, tension, and the leftward part of friction does not cancel out. We have to figure out that component of this force. Subtract off friction, so it would be this component minus friction, that's your net force. It'd be sum them out that way. And then you write F net equals ma, and oh, I know that value because I just solved it, because I would be given numbers for all of these. And now I'll just write equals ma type in Appa's mass, you can figure out his acceleration.